Hello guys, my name is Saddam and welcome to my channel. Today we are going to do following videos on vectors from the Kleppner and Kolenkow book. So this is the another video on Kleppner and Kolenkow series. So if you are new into my channel, please subscribe and share with your friends. In the previous video we have talked about vectors, and we have told that in vector, when we are dealing with vectors, we choose some coordinate system, and with that definition we had defined some following thing, like what is the position vector, what was the position vector, what is the velocity vector, as well as what is the acceleration vector. So these were my definitions, and we have talked about like v is dr over dt. So it is like some known thing we have dealt, but still, as we understood something like coordinate systems are necessary thing, but we didn't follow that how if we are doing this kind of thing like time derivative of some kind of vector, then what is the meaning of this thing in the concept of vectors. So we will deal with, if you have book, we can see here 1.10 that the time derivative of a vector. This says that what is the fundamental meaning of time derivative of some vector. So some graphical representation you can show here, that if you have some vector a t, now we are actually interested in how this vector will evolve in time. So after some time, let's say t plus delta t, okay, this has evolved like this. It will surely make some angle theta and so on, but the thing is that we will follow the triangle rule and we will find the change like this. So the change in delta a is equal to nothing but a t plus delta t is equal to minus of 8t. Now you could have said me that okay, ये change कैसे निकाला आपने? How we have found this change? We have followed this triangle rule के okay, this arrow is starting from this point, so we will follow this arrow, then again go this arrow will be equal to this one, and if you're gonna solve, you will get this point. Now you can ask that how can we find that how this vector is evolved with per unit time? Okay, let's say the per unit change is delta t. We can write here delta t is equal to a t plus delta t minus of 8t, because we are interested in per unit time at what segment this vector is evolved. Now we are saying that this evolution is kind of a very continuous thing, like continuous changes in some vector. So this change is very minute, like delta t almost, this point is almost equal to this point, as if so we are going to apply this thing. Now we have this particular definition, like if we have this instantaneous change, we are representing with this instantaneous change dA over dt is equal to, now this is the definition of derivative as Newton has introduced in the calculus. If you have some following quantity and if you want to find the change of some quantity at some point, this is the way we are actually defining the definition of vector. So definition of derivative. So this evolution of any vector is actually following the definition of same derivative. So there is no change, and that is why we can easily write that v is equal to dr over dt and acceleration is dv over dt. So there is no too much problem. But we want to further understand if we have some vector, okay, like vector a vector, and now what is the meaning of the change in vector? Like this, the change in vector is very similar, like at and something like at plus delta t. So if the change, now the change could be like this, like the change could be like this, okay. So if the change like dA over dt, we are calling it change. So the change in the vector, or the rate of change in vector, if it is always going to stay perpendicular to a of t, I'm not talking about a t plus delta t. So jahan se from where it has started, like this one is the base a t. So the change in this vector, if it is going to perpendicular with this vector, then we are calling it that it is the vector is rotating. Vector have or pure rotation. Now what does it mean by pure rotation? Like circle, you have the center and you have this radius. So these radius are always the same. So the pure vector means that if this vector a of t is there, now from after the evolution, this a t plus delta t will be same as in magnitude of a of t. Means that means that it is like a radius. It is like a radius vector, that the length of the vector is not at all changed. So if this happens, then this change will always be perpendicular, like dA over dt is gonna be perpendicular to this a vector. So that is the very interesting thing with this result, that yeah, we got something very much interesting. Okay, so let us see here, and we try to understand that how this happens. Like a vector is here and you have this a dash, and if it is gonna perpendicular, so a is equal to a dash in the magnitude. Now similarly this happens and this happens. So the geometric meaning of the rotation of some vector is like this, that the change will always be perpendicular to that the base vector. Like delta a is vector of a. Now delta a prime is gonna perpendicular with a dash, delta a double prime is gonna perpendicular with a double prime. So that is the very much meaning. And if you want to find the some change in if a particle is moving in some circular path, so this is the way to understand it. So whatever we have talked here, like it is in instantaneous change. Now if we have the finite change, now we can say that what is the meaning of finite change? The meaning of finite change is that if we have a vector at1, after some time the vector is at2, and if it is making an angle like del theta is your change in angle and so on. So maybe this is your delta a, and I'm not here saying that it is actually making perpendicular to this thing. What we can draw here is that we can draw a bisector which bisects this angle in two half, like delta theta by 2 and delta theta over 2. Okay, let's name it O, P, X, or let's say Y. Okay, now we can establish a very interesting result here. And you may ask that how can you make a very interesting result? You see, if I am here like in a big triangle like OXY, in triangle OXY, if you see here, like if I'm going OX, then XY vector is equal to going to give me OY vector. OX is 80 plus XY is delta A, and is equal to OY will be something like 82. Now here you can see here like this delta A consists of XP and PY. So we can see here like delta A could be like XP vector plus YP vector. Now delta A is not perpendicular on, delta A is not perpendicular on 81. So this is the meaning of finite thing. Okay, so in there we had this very infinitesimal change. The change is very small, and let's say we have some finite change. So in finite change, what happens to this delta A if it is not perpendicular? So we have made that, okay, we are actually doing this bisection, and this bisection like YP is perpendicular to OP. Okay, and now this one XP is perpendicular to OP. Okay, but not delta A is perpendicular in 81. Very good. Now we can employ some trigonometric result like sine delta theta over 2 is equal to, we can write here very simple result like py over for here the hypotenuse is 82. Cool. And again sine delta theta over 2 is equal to, now in this triangle, like triangle we have OPX. Okay, and here the triangle was OPY. Okay, so this was triangle. Now we are in this triangle, sine del theta by 2 in this triangle. So for this triangle, this is my hypotenuse. Sine delta theta is XP over 81. Cool. So we can write here like PY is 82 sine delta theta over 2, and px or xp is 81 sine delta theta over 2. Now we have this following, like we have this result which is waiting for us. Like we can write delta A is xp plus yp, so we can easily add these guys and we will get like delta A. Delta A will be now sine del theta over 2 is kind of a constant, is kind of a common, and at1 plus at2. Now we have given a following so we have a very interesting result and following comment that if this rotation is finite, okay, now if the rotation is if it is in pure rotation and the rotation is finite, so we are in pure rotation, sorry, and change is finite, okay. So this is most important, that we are in a pure rotation and change is finite. Now if we have pure rotation, then at1 must be equal to at2, because we are in a circular kind of change. Therefore we can easily write delta A is equal to at1 plus at2 will give you twice of A sine del theta over 2. Okay, so this is very interesting result, that it says that if you got a finite rotation and rotation is like this, so we have a 2A and sine del theta over 2. What if now we want to do some infinitesimal change, okay? Now delta, if infinitesimal change, then delta theta must be very much, delta theta by 2 must be very much smaller than 1. So we know if your sine theta is very much smaller, if your theta is very much smaller, then it is approximately equal to theta. So we can write here del 2A del theta over 2 is nothing but A del theta, just like that. Okay, so here we have the, if A is your constant, then the change in this one like delta A over del t, and if the change in very instantaneous, like A is your maybe constant, we can write del t, again limit del t goes to 0, therefore dA is by dt is A d theta by dt. Got it? So whatever the vector, whatever this vector will change, if this vector and this vector, the length is constant, like we are in circle, if he is drawing a circle, now radius is not going to change, there is no change takes place in this here, therefore this is treated as a constant we have. And whatever the change is here, the change in because of the direction, and direction is coming from here, and we are calling it, because we can write here like R, like suppose A is your R, okay, if A is your R, so we can write here dr by dt is equal to, we have R and d theta by dt give you omega, okay, therefore V is, see, V is nothing but R omega. Got it? So this is the very interesting result we have got. So the rotation of a vector or constant and the evolution of a vector, if the length is constant, we have a very interesting result, in a sense that it is actually leading us to something more concrete, and it is, we are calling it, we call it like the circular motion. So whatever we had done so far, we did so far is pure mathematics, but from here things have completely changed, and we have introduced the concept of circular motion from nowhere, out of nowhere. Okay, we can further develop this concept, like something is rotating in a circle, or maybe like there are some comets which having this kind of motion, okay, some spiral motion where the angle is constantly changing, but along with radius is changing, means that it is plotting a circular, but each time this radius is increasing. Therefore the rt1 is no longer equal to rt2, okay, but we can assume that this is kind of a again circular thing, and theta is again changing, my dear, because the angle is changing or orientation is changing. So to solve these kind of equations, what kind of coordinate system we can take? Means that if we have the following coordinate system like x and y, okay, and some particle is having some distance, at distance r vector, or let's say it is r hat in this direction, it is making angle theta, okay, with x hat, and y hat is this one, and some particle is changing. Therefore this, if r, because we have already seen that if your r vector is changing, okay, then this will always change, means the theta will always change. So one component will like this, okay, so this component we will call theta hat, and this will make some angle, like from here, like here it was 90, so this will be 90 plus theta. Now can we express, like here we had x hat, y hat, can we transform everything into r hat and theta hat? You see, in Cartesian coordinate system we had x dot y is equal to 0. A similar thing will happen, like r theta dot theta hat will be 0. Okay, but here we will follow the symmetry that if any particle is moving in a circle, we can use, because the variable are like r and theta. So if my coordinate is like a circular coordinate, it will be very much simplify for us, that we don't have to worry about what is my x hat and y hat. We can transform everything in r hat and theta hat, and our job is done. Now we will deal with, if you have to find the area of circle, we don't have to care about Cartesian coordinate system. We will always work with r hat and theta hat, and we will call this kind of coordinate system as a polar coordinate system. So this is the transformation of coordinate system. Now we see we had the notion of abstract vector, like multiplication, addition, and so on. Now in our hand we can always change our coordinate system from one point to another point, or let's say one frame to another frame, in some sense that now my coordinate system is like very flat Euler type. Okay, good, but we can have this coordinate system like this one, where r is going this way and theta will be going something like that. So theta will change this fashion, okay, and r will change this way, this way, this way, this way, and this round will give you the theta hat. Just like now x and y has transformed in this fashion. Now along with this we can also change this type of coordinate system in cylindrical kind of coordinate system, where we have the change in z also. So it is like a pile of some circles which is evolving in some particular z direction. It has some height. Now we will have like some spherical situation. So we could have like this guy and this guy, like in Earth. So it is a very 3D system. Like we have this r is changing, now theta is kind of changing, and one angle will also change, which is we call phi. So this is a spherical system. So from here we can move here, from here we can go here, and from here we can also generate this one. So we can transform our coordinate system from another variable to another variable, like x hat to y hat to r hat, theta hat, and again goes to, like in 3D system, r theta z, and in again if there is a not like one way is going up and so on, we would have like some spherical kind of situation, like r hat, theta hat, and phi hat. Okay, so from 2D we are going move in 3D, or maybe we can consider here x, y, and z, and so on. So r and theta is kind of very much 2D case, but r theta and z is 3D case. R theta and phi is very much 3D case. So this we call it, because we are choosing this kind of coordinate system, because we have some symmetry in our system. And to solve those problems, like for example, if somebody asked that what is the volume of cylinder, how can you find from integration or calculus? So you will gonna use this kind of coordinate system. So if you understand how to transform the Euler coordinate system into cylindrical coordinate system, then you can do all this kind of vector form and so on. If you don't, then it is again kind of a hell. So the Kleppner book is actually dealing with this kind of issues very amazingly. Okay, so like motion in plane polar coordinate system, like if you have a particle which is moving in a circular coordinate system or in a circle, what will happen? Or how can we express velocities? How can you express acceleration in this kind of system? So this is more interesting and this is more theoretical. So if you want to be a theoretical physicist, you have to understand what is the basic nature of a system. does it having any kind of symmetry or not, or can we make it more symmetry by transforming our coordinate system. So if you understand this transformation, it will be a great help to understand the general relativity. So that's why these concepts have greater meaning in the sense of its mathematical elegance, as well as solving a very critical problem in a simplified manner. So if you have, I hope you have liked or enjoyed this video. I know this video has a greater length, so I cannot help with this kind of it is not kind of a video you may expect in a YouTube, but yeah, I do make these kind of videos. Maybe if some of you are interested in physics, you will have some flavor. Okay, this kind of things we have to deal if I want to become a serious theoretical physicist. So my videos are for them. If you have enjoyed, please like my video and share it to your friends. Thank you very much. This is Saddam Leonardo Cap signing off.